I'm Anil Kumar, and I hope this review test is helping you out. And now you know all about equations of lines in R2. And let's move on with R3 now. So this question, given the line XYZ equals to -2, -3, -4, plus the parameter t and the direction vector 1, 3, 5, for every t belonging to R, we need to state parametric equation, symmetric equation, Cartesian equation of the given equation, and we need to find XYZ intercepts and the point of intersection with all the three planes. Now when you look into this question, then it's basically transformation of the equation from vector equation of the line to the other forms. Now as you know, for parametric form, what you should do, you should find what x is in terms of the parameters, right? So I will do for x, for y and z you can do yourself. So for x we can write x is equals to -2 plus t, right? Well, we can write for y and z also here, y equals to -3 plus 3t, and z equals to -4 plus 5t. So that is how you transform your equation from vector equation to parametric form. In case of symmetric form, you're trying to isolate t, right? And since t is in all the three and the same parameter which is to be used for a point, all of them will be equal. So that is the basic concept. So t is equal to what? That is what you need to write. So we don't write t equals to what, but that is what is assumed, and that's how you get the symmetric form of the equation. So we can transform it and now isolate t. So when you isolate t, you get x plus 2 here, and when you isolate t from this, you get y plus 3 divided by 3. Now both are equal to the parameter t, so both should be equal, right? So that is the concept of converting one form which is parametric into symmetric. And for z, it is z plus 4 divided by 5. Now there are two things which I would like to state here, and that is, suppose if it was only z minus 4, not that t was not there, in that case what will you do? Right? So then it will be z equals to -4 only, since you cannot divide by 0. Remember that. And another thing is that if there are two such things, for example, here also in y we had just -3. Do you understand? In that case, you would have written y equals to -3. Then the symmetric form of the equation will not exist in this fashion. Do you understand? So a symmetric equation in R3 will exist really if we have, at least t parameter, if it is not along a straight line in XYZ direction. Do you understand? If I say equation of x-axis in symmetric equation, you cannot write that, right? Okay, next one is Cartesian equation of line. Now, Cartesian equation of line in R3. Now you have to tell me whether it really exists or not. Now see, Cartesian equation is the equation of a line which is based on the normal. But when you're talking about R3, the space, in that if you have a line, then for any line in R3, there could be infinite number of lines, right? For example, let us assume this is R3 space, and there is a vector which is getting into this space. So it's like an arrow going in, and you see this plus sign since the arrow is going in. In that case, every line which is normal to this arrow will lie on this particular page, and this page happens to be the plane defined by all those lines. Do you see? So there are infinite number of normals which we can draw to one line in R3. So Cartesian equation doesn't exist. In fact, it forms a plane in R3. So this does not exist. So it's kind of very important here to review this and understand why Cartesian equation of line does not exist in R3. So that could be another communication question for you. X, Y, and Z intercepts. Now to find x-intercept, y-intercept, or z-intercept, what you need to do is you need to find the values. You can start from this equation. You can substitute y and z equals to 0 and find the value of t. Now if you do that, if y is 0 and you're trying to find the value of t, so let's write down like this. Let me write for the time being this equation equals to t, for example. Let me write this equation equals to t to find the x-intercept and y and z-intercept, right? So if I put z equals to 0, t value is 4 over 5. But if I put y equals to 0, I get a t value of 3 over 3. But these two values are not same, right? So x-intercept does not exist, right? So it will not exist for this particular case, right? So it may exist, right? Sometimes the lines may cross from x-intercept and y-intercept, but in this particular case, it does not exist, right? Now, if you try to find y-intercept, then x equals to 0, you get t equals to 2, and z equals to 4 over 5. So that does not exist for this particular case. And for z also, you find t values being different. So it does not exist for all three of them. But that really doesn't mean that the x, y, z intercepts will never exist for any case in R3. Let's take cases now where it may exist, right? For example, if this is your R3 space, then a line which I'm drawing here, it has got two intercepts, which is x and y intercept. Do you understand? So it may exist, correct? Or if I have a line going through the origin, for example, so I'm just drawing with a dotted line. I can make this solid and then dotted going inside. It goes through origin and all the intercepts exist, right? And here I may have a line which could go like this. So you can have the x, y, z intercepts. It is not that you just can't have them, but there are cases, right? These are all special cases where you will have x, y, and z intercepts. But normally what you find is that the line will always have, or must have, is not always have, but most of the time have, x, y, they will cross in a plane. So any line if I draw, for example, I line this. So this point, it is going through the plane, right, which is xy plane. And here it is going through the plane which is xz plane. Do you understand? So the lines can cross the planes, right? Now here, if you want to find the point of intersection with xy plane, in that case z will be 0, right? So if z is 0, t equals to 4 over 5. Now you can plug in t 4 over 5 in your equations and find the point of intersection for xy plane. So let's use this space here to find point of intersection with xy plane. So in that case, z equals to 0, right? Now when z equals to 0, we get t equals to 4 over 5. Remember one thing, we have so many different forms of equations, and now you can see which form to use when, correct? So we use this form, say, well, z equals to 0, t equals to 4 over 5. Now when t is 4 over 5, we can plug in t as 4 over 5 for y and x and get the values of x and y coordinates. Do you see that? So x will be equals to, we can use this coordinate, equals to minus 2 plus 4 over 5. And that is 5 times 2 is 10, so minus 10 plus 4 over 5. And that gives us minus 6 over 5. And similarly, we can find y from here. So y is equals to minus 3 plus 3 times 4 over 5. So which is minus 15, and 3 times 4 is 12 over 5, and we get minus 3 over 5, right? So in this case, xy plane, the points which we get is minus 6 over 5, minus 3 over 5, and 0. You can follow the same method and find the point of intersection with xz plane and yz plane. So for xz plane, you'll put y equals to 0 and t will be 3 over 3, which is 1. And if t is 1, you get x points as minus 2 and minus 2 plus 1, which is minus 1 and y is minus 3 plus 3, which is 0, right? So like this, once you get that also 0, you know this equation will work for the other plane also. Now that is how we can do all these. So let me do this for you again because I saw that to be 0. So let's say we are doing point of intersection with YZ plane. So if we say, so let me do XZ plane first and then really check the answer here. So if I do XZ plane, so X and Z plane, that means Y equals to 0. If Y equals to 0, the value of t is, so we are doing point of intersection with XZ plane, right? I'm just squeezing in here few lines and I hope you can see them. Okay, for XZ plane, we know Y equals to 0. Now if Y equals to 0, then t equals to 3 divided by 3, which is 1. So t equals to 1. Now if I put t as 1 in my equation here, then what do I get? X equals to minus 2 plus 1, which is minus 1, and z equals to, yeah, we put y equals to 0, that's correct, y is 0, and z equals to minus 4 plus 5, which is 1, yeah. So we had put y equals to 0, so we got y, that is correct. So we get a point here for xz plane, which is this one, and the point is x value of minus 1. Let me write down the answer now here. For xz plane, x value is minus 1, y value is 0, and z value is 1. So we will get points like this, and you can calculate now the point of intersection with YZ plane. But with this, I hope you understand that a line can be transformed or written in different forms. Second, we can find all kinds of intercepts. Third, in R3, we do not have Cartesian equation of line, and simple reason is that there are infinite number of normals in R3 on a line, and they really define a plane, not just a line, right? So that is how we can answer this question, and I hope it helps you to get all the concepts together for vectors when we are dealing with lines in R3, 3-dimension or space. Thank you and all the best for your test on vectors. And I hope with this you do extremely well, as all my students have been doing. Thank you once again.